Well, there's only 11 questions on this thing.
So, I'm also a friend of
Our trick finals on Tuesday, right?
Tuesday day, week from tomorrow.
I gotta try to meet that day. Is there a way I can get it done on Monday or Wednesday?
Monday would be great. I'll be here.
Do they even get finals on Wednesday?
I don't. I think they're scheduled Monday, Tuesday, Wednesday, Thursday, but all of mine are grouped on Monday and Tuesday.
Okay, so I can try to get it done on Monday.
Just let me know, because I'm giving one at 12:20 and 2:30 that day.
Then I can sit with them.
Yes, just so you let me know to bring it though. Because it'll be a separate stack. But that's fine.
I can just get it done during the same period that we're doing this one. Probably.
You mean,
Like, cause it's.
I see. You want me to bring both to this one?
Yeah.
You want to do that?
Wait, what?
He wants to take his trig final and this final together in the same
I
period.
mean,
That's great.
if that's what
That's convenient for me, but I don't think I'd want to.
I
There'd be so much swimming around.
I feel like I probably end up.
Well, you look at that practice that I just posted for trig, and you see if you want to do that.
Drake gets a practice.
What's that? Trig does have a practice final. So, but look, this is exactly what's going to be on the final. So what I'm saying is comprehensive, covers chapters 1 through 6, specifically the material covered on quizzes 2 through 10. If you staple those together and rework 2 through 10, which you should have copies of graded, that's a great practice test. So you can make your own.
That's
Right.
quizzes too.
Quizzes 2 through 10, notes, and homework assignments. But I say this is a good succinct review. But those that you feel you have more practice needed, go back to your homework assignments and pull those out in your notes. Right? And here is exactly the topics covered. Why don't we go backwards rather than from the beginning? Because this seems so old. This is what the test Wednesday is on. The last three here: integration, finding the area under a curve or area between curves, like those two quizzes I gave you, right? And applications of integration similar to the ones from chapter 6. Okay? That's what the test on Wednesday is like. And if you can do the test Wednesday, you've got this all studied for, don't you?
Yes.
Now, do some of you remember what implicit was?
That's when you tackle the
If there are equations in y and x, every time you take a y derivative, you tack on what? And then you solve for dy dx, don't you, in terms of x and y. We know how to do that. We know. We've learned, right? This was just on the last test recently, wasn't it? Finding the intervals of concavity and inflection points. What was that dealing with? Second derivative, right? Number 7. Do you see how we feel comfortable? We're already going backwards. When we got up to here, we know all of this, don't we? We're feeling great. We're happy, right? Okay? Relative and or absolute max and min points. That was the end of the, end of the second test, where I said find the absolute max min. I would give you a function, maybe in an interval, and I would say you would find the derivative, you would find the critical numbers, and you would test the endpoints, wouldn't you? You would pick the highest and the lowest, wouldn't you? That's what that's talking about for absolute. Relative was just all the critical numbers, right? If it was a continuous function, you would find all the critical numbers and classify them as max or min. Remember that. Okay? Finding, that was when we first started derivatives, number 5. Finding the intervals where a function is increasing or decreasing. We would find those critical numbers, and we would split the x-axis into intervals, wouldn't we? And we would test a number from each interval into the first derivative and say what? If it was negative, it was decreasing. If it was positive, it's increasing. We remember it a lot, aren't we? Good? Okay?
Just not getting it.
Major applications we've done in here was like marginal cost, marginal revenue, marginal profit, where we took the derivative of C, R, and P.
So we're not doing the
I'm not. There's not going to be. I don't think. If it's not on here, I didn't give it to you. So there's not an applied maximum problem on the final. Yeah. Let's see. Yes, finding the equation of a tangent line to a curve, getting a little older, isn't it? But you remember, didn't we just find the derivative at a certain x value, and that was the slope, and we wrote our equation of the line? Remember that? Okay. Derivatives, and this might be where you have to study the most. Go back and practice taking limits of different types. When we did that in chapter, was it 2? Was it chapter 2? A long time ago when we first defined limits even before derivatives. So what I would have you do is pull out quizzes 2 through 10, go through them one by one. Do I remember how to do these? If not, you try to come see me. We won't have another class period, will we? But when you start reviewing this, you know when I'm in the office. A lot of you come down and see me. And I'm glad to see you. All right? Or you email me, you call me, you say, listen, I don't remember how to do this problem. Can you help me? And I'll say, yes, I'll try. With the phone. But this is basically it. No surprises. And I think, if I'm not mistaken, I'm thinking there were like 30-ish questions, so they didn't count that much apiece. All right? So I'll tell you for sure Wednesday how many. I'll go back and look at the test and count, make sure I didn't delete anything. But this is, I made this review straight from the questions on the final. If it's not here, you should say, that was not on your review, and I have an issue with that. And I bet you would. And you would have every right. Okay? And I will show you where that question fits in to one of these 11 headings. Yes?
The final is Monday at
2:30 to 4:30. I'll try to be up here at least by 2:15, but I think I give a final from 12:20 to 2:20, but I'm hoping they all finish within the 2 hours so I can go get my other books and come up here early, because if you want to start, you don't want to stay to 4:30, do you?
No.
I don't want you to. You do, so you don't be here anyway. So you're going to take every minute of your time. That's good, that's fine.
I'll stay for 30 for you.
And it's in this room, right?
It's in this room? Yes. Monday. What's Wednesday though?
It's quiz.
Test 4.
Oh, this one's good.
What else is due Wednesday?
The two take-home quizzes.
Quizzes 9 and quiz 10, right? Have you worked on those yet? Some of you have.
A little bit.
Okay.
We can come to you with any questions.
Yes. What I need to know, and I'm willing to answer any questions you have on any of this, but I thought we would concentrate on the recent homework. Are you getting those integrals? Are you getting the area between curves that I assigned? If there's any of those we should work, let's do those. Or if you have your quizzes and say, I don't remember a certain type. Someone pointed one out that I think we didn't actually do much with. This is in your D2L notes. But do you remember, what number was that, Jordan?
Oh,
What was that one with 4 to the x in it?
it was.
Is it C, 1C? It says e to the x, something e to the x plus 4 to the x.
Yeah,
Yes.
one thing.
This is how you do it. Remember when we took the derivative of a to the x, didn't we say it was a to the x times ln a? To go backwards, you have to divide by ln a. So if you had an antiderivative of 3 to the x dx, what would that be? 3 to the x over ln 3 plus c. So that's part of 1c on your quiz. When it says 4 to the x, you have to use that rule. So I threw that in, and I think I forgot to do one, because that's another one that they don't put in your book, but it was in previous books. So, but that's easy, isn't it? Okay. All right.
And that was from the last section? That question there was?
That was from quiz 9.
Oh, was it-
1C on quiz 9. But are there there any of those Chapter 6 homeworks that you had trouble with, or anything from a quiz that you really feel we need one like it? I won't do it, but I'll do one like it. I'm glad to.
Could you do, let's see, what is it, 31 from 418?
Oh, that's pretty good. This is page 418. 31 says, integral, and you see what it is, but you see the major function is downstairs, right? I'm going to rewrite 31 as 1 over e to the 3x plus x cubed. And that's raised to the third power. And I'm going to shift the numerator over x to the dx. I'm going to write it e to the 3x plus x squared dx. You see what I did? I shifted over that numerator next to the dx.
Is there any kind of a trick to know exactly, like on one of the other columns it was like 3x squared plus 4, and then the other number on top is 6x.
Mm-hmm.
Is there a way to, I mean, I know you said to take half of this, I think, but to make sure that it's going to be the same, in other words.
Well, yeah, what we want to do, and in fact, once I write it like this, I'm going to call that negative 3, won't you? So I'll call that e to the 3x. E to the 3x. And it was plus x cubed to the 3. Plus x cubed, and I'll call that to the negative 3. So I rewrote 31 so we could work it a little easier. What's the derivative of the inner? The derivative of this is itself times 3, isn't it? 3 e to the 3x. What's the derivative of that? 3x squared. Well, what do I need to make it complete? I need a 3 here, and I would put a 1/3 outside, wouldn't I? So now, the derivative of this inner is complete with the dx. And I would disregard that, and I'll say my antiderivative is 1/3 e to the 3x plus x cubed to the what? Yes, negative 2 divided by that new exponent plus c. And if I want to write it a little better, I could say 1/3 times the negative 1/2 is negative 1/6, or I could drop this down and call it negative 1 over 6 e to the 3x plus x cubed squared. Would you agree with that? Plus c? You see where I got the 6 and the negative? Put that out front, drop this down, and that would be a great way to write your answer. Now the book might leave it negative 1/6 e to the 3x plus x cubed to the negative 2 plus c. Doesn't matter either way. Both of these would be correct. Make sure you see that is a negative here. It's sort of hard to see. Not much better. But you see that? We saw what the major function was. It was this to the negative 3. The derivative of this was 3e to the 3x plus 3x squared. If I put a 3 and a 1/3 outside, that balanced it. Then I just disregard that whole derivative of inner, and I use my power rule on that. Oh, and you got it. And if you took the derivative of this, you should get exactly the original function back. Okay. Any other particular questions from that homework in chapter 6? Or ones like on your quiz that you thought, I don't know what to do? 13 on 439 says f of x is 1 minus cube root of x. Can I call that x to the 1/3 if you don't mind? And they say from -8 to -1. Find the area of the region under the graph. Okay. So would you agree with me that that's going to be the integral from -8 to -1 of 1 minus x to the 1/3 dx? That's going to be what? X minus 4/3 over 4/3. And I'll run that from -8 to -1. Let's write it a little better before we plug it in there. Let's write that x minus 3/4 x to the 4/3 from -8 to -1. And then let's do that. If I plug in -8, -8 to the 4/3, the cube root is -2. To the 4th, you put 16. Times 3/4. Wow. Times -3/4, yeah. So -48/4. That's if I plug in the -8 in both places. Minus, if I plug in -1, that's a lot less work. That's going to just be minus 3/4. If I plug -1 here, the cube root is -1, but -1 to the 4th is 1, isn't it? If I distribute a little bit here, let's see. I've got -8 minus, well, 48/4 is actually 12, isn't it? Plus 1 plus 3/4. Is that going to be -20 plus 7/4? That's going to be -18 in the 4th, is that right? Okay. I want to show you why that is. Would that be, did they give it 18 in the 4th? They give it 73/4? They did 18 in the 4th? Okay. Let's look at our graph, and I want to show you why. I wondered about that. If we go ahead. It's top minus bottom. Oh, did I? Ta-da.
This is what they did in the book.
Yeah.
Why
Yeah, it's top minus bottom. So I should have put this minus this. You're right. So that's going to give me the opposite of it, which would be positive, wouldn't it? Because this would have been -20, that would have been minus. Right? Okay? That's it. Why did I do that? I know it's top minus bottom. I guess I was just talking and writing at the same time. But yeah, so let's verify this with our graph though, because it should be above the x-axis to be a positive area. So if I graph it, what is that? Is 1 minus x to the 1/3? 1 minus x raised to the 1/3. Okay. If I graph that, it's new 6. See that? From -1 to -8, right? be from here to here. That's a positive area. Isn't it? So if I would have plugged my top in first minus my bottom, I would have got the positive 18 point, and that's exactly what it should be. Okay? And that sort of verifies it. If I would have gone maybe from 1 to 8, it would have been a negative area. Right? It would have been below the x-axis, and that would have been a negative area. Okay? But that's positive, definitely. Thanks for catching me. I was just talking to you. Plug this number in, then plug that number in. Very good. Very good. Are there others that gave you trouble? If you don't have other particular ones, why don't we go to the chapter review and pick out a few good ones from that I think that you get to study for the test. Really. You see on page 481? I might be interested to see if you could do number 8. What's the integral of x plus 1 dx? See if you can do that. And then I'll try to pick out some other ones. What's the derivative of the image? Is it 2? So I need a 2 with the dx and a little that side. Do you do with that? Okay. Once I do that, I'll disregard that, and we will say 2x plus 1 to the 3 halves over 3 halves plus c. What would happen if I made that 2/3? Right, if I put 2/3 up here for this, the 2's would cancel and I would get 1/3, 2x plus 1 to the 3 halves. And that would be here. Would you agree that if I took the derivative of this, derivative of outer times derivative of inner, I would get this back once I cancel and simplify? Everything would go back to just 2x plus 1 to the 1 half. Always good to check if you're not sure. Take the derivative of your answer.
Did we do one that's like on quiz 9?
Yes.
That's a question on that.
Yeah. What if I made one up? Similar to that one. What if I said, What if I changed it to this? Very simple. Would most of you like that as well? What's the derivative of the limit? 2x minus 2. Right? So I guess I should have made that a little better. I made that a little, right? If that's 2x minus 2, what would I need? I would need a 2 to make the 2x minus 2 and a 1/2 outside. Okay? Once that's done, I'll have the 1/2 outside and I'll disregard this. What will be my impact? To the 4/3 over 4/3. Let's see. What would I put outside like for the bookends? What would, if I put 3/4 there? 3/4? Would that be 3/8? X squared minus 2x to the 4/3. Let's see. Very similar to that one you asked me about. You have to adjust it. Once it's adjusted, just disregard your du and use your power rule on the major. But I promise, if you staple quizzes 9 and 10 together, that's very similar to what you're going to see Wednesday for your test. It's a 2-page test. It's almost the same number of projects. You feel comfortable with most of those, all the quizzes. If you don't, I would say go back and look at those sections in chapter 6, the homework, like in 6.2, 6.4, and 6.5. Make sure you can do those. Most of you got a good handle on those last ones on quiz 10, where we had the definite intervals and the area bounded. Didn't we say it was always top curve minus bottom curve? You want to find the area between these. Got to graph it and figure out which is top, which is bottom. Subtract them. Find the x-coordinates where they intersect. But until you try these quizzes 9 and 10, you're not going to really know if you can do these or not. So I need you to try these between now and Wednesday. If you want to bring them by, I'll tell you if they're right or wrong. You know, if you've already worked on some of these and want me to check them, I'll go before you leave today. Okay? Yeah. Why don't we go back to chapter 2? Look at the end of chapter 2. Let's see if we can pick out some good limits and see if you remember what types they were. You see on page 153? What did we say? Now, a lot of them at first, like number 15, couldn't you just plug the 2 in and get the limit? Those were easy, weren't they? But if you start to have something with a bad situation, yeah, like 16. Why don't we try that? 16 on 153. The limit is x approaches negative 2. X squared minus 2x minus 3. X squared if I plug negative 2 in directly, I'm going to get a 0 denominator, right? 4 minus 10 plus 6, yeah. But hopefully I can factor. Can I factor? This one's easy. 3, 1, minus plus. What's downstairs? So those will cancel. So now if I plug in negative 2, I still have a problem, don't I? That's the problem. That doesn't cancel. Excuse me. So we said x minus 3, x plus 1. And then we said x plus 2, x plus 3. If I copied that right. So nothing really cancels, does it? Well, we know we get a 0 denominator, don't we? Right? You know what would probably be easiest to figure out for this one? If we graphed it and looked where the asymptote is at negative 2, right? Let's see what it does when it's approaching negative 2. What would that be? If we graphed, now call out that numerator to me. 3 divided by x squared plus 6. I did copy all the signs correctly. If I went 0, 6 on that, do you see that when x is negative 2, that asymptote? Are both sides going to infinity? So would you say that that limit is infinity? They're both increasing forever, right? This book might say does not exist since it's not a number, but I would say that that limit's infinity because it seems to be increasing forever for both sides of negative 2, from the left and from the right. I would count that correct. The book might say does not exist because there's no number, but the way we were doing it, we said if both sides approach the same value, which was infinity, that would be the limit. And you could probably prove that from your table if I got very close to it. If I got very close to negative 2, like negative 1.999, large number. How about negative 2.001? That's not really what it said. I wonder what's going on. Is that right? Yeah, because negative 1.99, you see that from the right, it's getting huge. I was thinking that if you got very close from the left side, it should also be positive from that graph, wouldn't you? I'm trying to figure out why that's not there. What if I change the window? What if I went up to 3? How's that? Still looks like it to me. Negative 2. That's weird. Look at that. And if I put in negative 2, of course it's not defined. That's so strange. I guess that was a bad example to look at. But I would have said from that graph, it seems to be approaching infinity for both sides. So I guess we would have to say it does not exist, right? So, since our theory wasn't behaving, that's so strange. You know what? Let me go in a little closer here. If I said my window was from, how about negative 3 to negative. That's baffling. Ah, you see what that did? You see what that did? As you get close to negative 2, from the left it goes to negative infinity. There's a loop down there that we couldn't even see on the window I had. That proves it does not exist. One side goes to positive, the other side goes to negative. There are not any on your final that are going to be that sort of tricky. But we figured through it, didn't we? It does not exist. That was interesting. We couldn't see that loop at all, could we? Because it seemed to be just this piece up here, right? And if I went a little further, you could see that piece. So it had a loop down here. This is what I would tell you to do. If you go back, let's see exactly what numbers was it. Quizzes 2 and 3. Look back at those real quick if you have them. You see quiz 2, if you remember all those type limits, those are the types that I'm going to ask you. All right? Starting with number 2 on quiz 2, 2 and 3, those are great. All right? 2b was where you had to factor and cancel to actually get your limit. Do you remember some of these just to review? The limit as x approaches negative infinity. Actually, that's positive. 1 over x plus. What did we say about that type? You remember? All right. If I divide everything by x, right, this is 1 over x over 1 minus 5 over x. You know that as x goes to infinity, these will go here. 0 over 1. That's a good one to look at. All of those, you could use that little device if you divide by the highest power of x in the denominator. Now, 3c is sort of a tricky one. Some of you didn't like that one. If you go to negative infinity, x squared plus 3, you know if you square a huge negative number, it becomes positive. What does that mean? That goes to infinity. You put in negative 1 billion, square it, and add 3, that's a huge positive number. That makes infinity. But the classic one is like 3b. The limit as x goes to negative infinity, 5x squared over 3 minus 2x squared. What would I divide everything by? Divide everything by x squared. So that would be the limit as x goes to negative infinity. 5 over 3 over x squared minus 2. Where does that go? 0. So what's that limit if that goes to 0? Also on quiz 3, that was practice with left and right hand limits. You approach from the right with a little plus or from the left with a negative. So just look back at those. What was our rule for 2a on quiz 3? You see that? The limit as x approaches 2 from the right, 2x over x minus 2. remember there was a theorem we had that said if you go a little to the right of 2 and put it in there, what would the sign be? Well, if I put a number like 2.001, is this positive or negative? So that we go to positive infinity. That was the theorem for those. Because if I just plug in 2, I get a 0 denominator, don't I? But we said that theorem said that if you put a number very close, if it's from the right to the right of 2, what's the sign on it? If it's positive, it goes to infinity. If it's negative, it goes to negative. And you could verify that from the graph also. And remember, I think 2e, or the one beside 2a, it should be 2b. The limit as x approaches 5, 1 over x minus 5. For that to exist, the right and left hands have to be the same, right? Remember that? From the right, if I put in 5.01, it goes to infinity. From the left, if I put in 4.99, it's negative, it goes to negative infinity. So that's why that would not exist. And you can see that from the graph because the two pieces would be what we were trying to do with that other one. I don't think I asked you to state that, but limit definition of derivative. Limit f of x plus h, remember? No, it's just, remember, it's the difference in y's over the difference in x's. So that would be your limit definition of derivative. But we always just used our rules after I defined it. And we were so glad that you did not do it on the But I won't ask that. But if you just sort of review those quizzes, if there's anything you come across that doesn't strike your memory, you just need to come see me about it. Do you see that starting with quiz 4, that's when we started with our rules of derivatives. Then it started to get very much more ingrained, right? This stuff is a little far back, but everything else when we started our, product rule, quotient rule, power rule for derivatives, those should be pretty familiar. Like I said, on the test Wednesday, we get so used to going backwards. When you get to Monday's test, don't forget to study your derivatives and antiderivatives. Be able to go both ways, right? So I don't want you to get those, jumbled up. But look at that again. Except for reviewing those, quiz 2 and 3 on limits, the rest of this I think will be pretty familiar, right? Don't you think? Are there any other types that you're concerned about that I've listed there? It's just reviewing it. I think once you look back at these quizzes with limits, you'll go, oh yeah. And if not, you need to see them. But we did the ones that I thought were most important, like that theorem, the ones where we approach infinity, we divide by the highest power of x. So, good. If any of you have worked on those quizzes and want me to check them before you go, I'm glad to. But really, unless you have other specific questions, this is it. This is your final. This is your final Monday, your test Wednesday. Test Wednesday, though, over these last 3, over chapter 6. If you look at quizzes 9 and 10, you're going to do well on